In this video, we're going to get started on long-term memory. And in the previous module, we talked about more shorter durations during which people hold information. But of course, there's this massive amount of information that we actually store for more long-term use. Now, long-term memory comes in several different forms. And one big distinction is the distinction between explicit long-term memory versus implicit long-term memory, or if you will, explicit being declarative long-term memory and implicit being non-declarative working memory. Now, what is the distinction between those? Pretty straightforward, really. Explicit long-term memory is stuff that you can talk about, that you can declare, whereas implicit long-term memory is stuff that you have stored in your system, but you don't show it through actual verbal responses, you show it through behaviors. And you see that under that umbrella, there's a couple of different versions of that. So long-term memory, first of all, is different from working memory. In the working memory model, we saw that there was a component for phonological information, for visuospatial information, and then the central executive that organizes all of that and directs information back and forth. In that model, long-term memory is really a separate entity from which the central executive sometimes pulls information, but it's not part of the working memory model. So here you have it. In the working memory model, the central executive pulls information from long-term memory. Long-term memory is also different from short-term memory. So there's a couple of reasons for that. So first of all, we know that when people have damage to a very specific structure in their midbrain called the hippocampus, they have trouble with forming long-term memories, not with short-term memories. And we'll see an example of that when I start talking about the link between brain impairment and what kind of memories disruptions that leads to. But there's good evidence from that sort of work that long-term memory and short-term memory are different from each other. Similarly, when you have a concussion or something like that, so for some form of head trauma, oftentimes people have trouble remembering what happened right before they got the concussion, but not for much more long-term memories about their childhood and so forth. So again, short-term memory gets affected in that case, whereas long-term memory is largely preserved. In general, there's also been research to document that accessing information from short-term memory is actually easier than from long-term memory. So that's another reason. And then we also actually saw in the serial position curve the way in which people remember information from lists of words. There's this benefit of the first couple of words and the last couple of words. And we saw in the previous module that the first words are actually better remembered because they seem to be in long-term memory. The last couple of words are better remembered because they're still in short-term memory. So what are we going to talk about in this section on long-term memory? Well, a couple of different issues. First of all, I'll say a couple of things about how long-term memory is organized. And then we'll get to more of the processes involved in long-term memory. A first process is called encoding. And this is really how do you get information into long-term memory? How do we encode it so that it's there for the longer term? Second, how do we retrieve it? If it's in there, how do we get it out? And then third, does forgetting really happen in long-term memory? And if it does, how does it work? If it doesn't, how come sometimes we can't access information? So in terms of its organization, I already laid this out, the distinction between declarative and non-declarative memory. And really you can see it nicely here in this picture of Albert Einstein. Albert Einstein obviously has a tremendous amount of declarative knowledge about physics, where he can write formulas, explain to people how physics work, and so forth. So that is declarative memory. He can declare it or make it explicit and write it out on paper. If Einstein gets on a bike, however, while he was still alive, he is using another form of long-term memory in the sense that he is in some ways displaying an understanding of physics by operating the bike and not falling on the ground. Both of these are long-term memory systems, but they involve a different sort of currency. The way in which they're expressed is different. Declarative or explicit memory can be expressed by verbalization. Non-declarative memory is displayed by skills and by behaviors. Within declarative or explicit memory, there's also another subdivision that's important. That's the distinction between semantic memory versus episodic memory. Semantic memory is memory for general facts that are shared with the rest of the world. So for example, which country you're from, or not even what you're from, but which country you live in, how many people live in that country, what the states are, what the capitals of those states are, what the birds for each state are, what kind of forests there are. All these kinds of general facts about the world are part of semantic long-term memory. On the other hand, there's also more personalized long-term memory, with information about the course of your life, your name, where you've lived over the course of your life, who you know, what kind of friendships you've had, what kind of sports you've played, and all that sort of stuff. So that is episodic long-term memory. It's much more about your personal experiences. Now, how is memory organized? Interesting question. And let's first just think about this for a second if we look at these pictures. You see a couple of birds, you see some fishes, and then you see two government buildings, the White House and the Capitol building in Washington, D.C. Now, it seems like if you had to cluster these pictures, you would probably put the Capitol and the White House together, you'd probably put the birds together, and you'd probably put the fish together. And if I told you maybe to make more refined categories, maybe you would separate the eagle from the other two birds because it looks kind of different. So how is that organized? Are these completely separate categories? Well, not really, because if I were to ask you, could you list an item that you see here that is related to the Capitol building and the White House? Well, out of those animals you're looking at, I bet that all of you probably would pick the eagle, because the eagle is also a symbol for our government. So how is this organization accomplished, is a question. One idea is that our long-term memory is hierarchical in nature. And there's some evidence for that possibility. And what they did in this study is that they gave people lists of words in random order, and they would just read them to them, but they used two different experimental groups. In the one group, they just started reading off the words. So they would, for example, go platinum, copper, steel, sapphire, marble, lead, brass, and so forth, without giving them any sort of structure. And then after they read the whole word list, they were supposed to recall as many items as they could. In the other condition, they told people, I'm going to read you a list of words, and they contain different kinds of minerals. Some of them are metals, some of them are stones, and then within these metals, some are rare metals, some are common metals, some are alloys, and so forth. And then they went ahead and read them the same list in the same order. What they found in that case is that the group that was given the structure actually did better on their memory recall than the group of people that were not given that structure. And why is that informative? Well, it suggests that by giving people that hierarchy, it actually helped their memory retrieval, which can then be taken as some evidence that maybe knowledge for these kinds of things is actually organized in a hierarchical manner, just like you see here, right? This is a hierarchy. There's a larger category with smaller subcategories, and then under the smaller categories, there is yet smaller categories, and then there's particular instances. So that's a hierarchical organization. Another possibility related to this, they're not necessarily mutually exclusive, but it's also possible and likely that the way in which semantic knowledge is organized is actually through some sort of network. And the way this works is that, for example, if you have the word bird, there's all sorts of aspects of a bird. There's different examples, there's penguins, there's canaries, but then there's also that a bird is an animal, that a bird eats seeds, that a bird can fly, and so forth. So it may be that in our brain, if we simplify this and we just think of, we have one neuron that corresponds to bird, that neuron would be related to a bunch of other neurons that represent the features of that particular category, that bird, right? So there's a neuron bird that's connected to a neuron wing, a neuron for tail, a neuron for animal, and so forth. And what happens then is that when we activate the word bird, that neuron fires, and it might actually spread activation to other neurons that are connected to it, so that when you activate the word birth, you actually at some level are also activating, seeds, fly, penguin, canary, and so forth. So that is another possibility. And it's actually possible with a network example like this to create hierarchies by having larger categories more or less connected to each other, and then the subparts that are more detailed sort of organized below these larger categories. So that's a first starting point for how long-term memory may be organized. Now we're going to talk about how we actually get information into long-term memory.